Yes, I'm sorry. So now the question, equation of the tangent of this curve is given by, therefore equation of the tangent of this curve of the tangent is given by, or will be, the equation of the tangent of this equation of this curve will be given by y minus small y equal to d by dx, okay, into x minus small x. Let me write it above. What is d by dx is this? So we get the equation of the tangent line y minus small y equal to d by dx is this. This is nothing but a y minus x square divided by y square minus ax, okay, into x minus small x. Okay, now substituting, okay, cross multiplying this, so we get, what do we get here? This is y square minus ax into capital Y minus y into this y into y square minus ax. Let me write it as it is. Okay, equal to, this is a y minus x square into capital X, and this is minus x into, okay, sorry, minus a x into a y minus x square. Alright, now separating, okay, taking this x, coefficient of x here in this case, this will be, let me take that positive, this will be x square minus x will be positive, so x square minus a y into capital X. Here it is plus y square minus ax into capital Y is equal to this, that side. So it will be y cube. Let me multiply this, write it here. Okay, y cube, and this is minus sign, so it will be positive. So y cube minus axy, alright, and this is nothing but minus axy, already minus plus, this is x cube. Here we will have x cube plus y cube, okay, minus twice axy, but what do we have? X cube plus y cube is only 3axy. This is from the first, let me take. So x cube plus y cube, that means 3axy. This is 3axy minus 2axy, that is equal to axy. Okay, the final equation is x square minus ay capital X plus y square minus ax into y is equal to axy. This is the required equation of the tangent of part B of question number 50. Okay, this is the equation on answer. Now let me take the C section of this. We solve all the questions. The C section of this is given to the similar type of question. What is that? This is the process of finding out tangent line. First of all, we have to find out the derivative, differentiation of the given curve, equation of the curve, okay, equation of the function, and after that write the equation of the tangent line, and in the tangent line we have to find out, we have to substitute the value of d by dx, and finally after simplifying this we have to simplify as much as possible of the equation of the tangent. Only then this answer will be there. Okay, so now let me take the C part of this. C part is x raised power n oblique a raised power n plus y raised power n divided by b m equal to 1. Okay, again finding out the derivative of this equation. Let me take differentiating this, differentiating it with respect to x, with respect to x here, we get, so this is nothing but m into x raised power n minus 1 oblique a raised power n plus this is m into y raised power n minus 1 oblique b raised power n into d by dx. Because y is not x, so we have to differentiate this with respect to x. Okay, so we have to differentiate y again. So now finding out d by dx from this. D by dx, there is another method of this, which is through partial fractions. Okay, so that partial fraction, through partial differentiation. That partial differentiation method is still not discussed, so I'm not taking that method. So that gives directly minus del f upon del x divided by minus del y upon del x. Okay, that is with negative sign. That value I'm not writing here because that is shortcut. But here also we can find out shortcut d by dx is equal to minus value of dx upon dy. So I mean this value, whatever definition of this term which is in terms of x, this is nothing but m into x raised power m minus 1 upon a raised power n divided by m this y raised power m minus 1 oblique b raised power n. M cancelled out. Okay. So this is the value in negative. So we have this is x raised power n with negative sign minus 1 upon a raised power n oblique y raised power m minus 1 by raised power m minus 1 divided by b raised power n. Okay, so cross multiplying this is value of d by dx. Therefore, equation of the tangent now. Hence, equation of the tangent. Equation of the tangent for the above or for the above, that is for the above function, for the above function will be, okay, again y minus small y is equal to d by dx into x minus small x. Okay, so now substitute value of y here, let me write it here. So equation of the tangent line, which will be y minus, this implies that y minus small y is equal to d by dx is this. This is minus x raised power m minus 1 on a raised power m of b or divided by y raised power m minus 1 on b raised power m into f minus 1. After cross multiplication, we get the cross multiplication. Take this with this side. This will be y raised power m minus 1 upon b raised power n into capital Y minus, now this is y into this value. Y into y raised power m minus 1, this is power 1. So when bases are same, powers are then this is y raised power m only divided by b raised power n. Okay, so this is equal to, similarly this minus sign. Here it is minus sign x raised power m minus 1 oblique a raised power m into capital X minus minus plus. Plus sign. Again, this is x. So x into x raised power m minus 1. That means x raised power m only upon a raised power m. Okay. Now taking this coefficient of x, capital X, this side, you will have x raised power m minus 1 upon a raised power n, capital X, plus y m minus 1 upon bn, okay, into y is equal to, this equation is xm upon an plus sign, this is ym upon bn, which is nothing but equal to 1 from first equation. And this is equal to 1 from first. So substituting this value, x raised power m upon a raised power n by plus y raised power m upon bn is equal to 1. This is equal to 1. This is the equation of the tangent line. That means x m minus 1 upon a raised power n into x plus y m minus 1 upon b raised power m capital Y is equal to 1. This is the equation of the tangent line. Sorry, tangent of this equation, C part. Now let me take the D part. So this is the D part we have done. Now let me take what this D part says. So D part of this equation gives us, okay, now equation 5th, question number 5th, part D. What D says, y is equal to, this is C cos hyperbolic x upon C. Okay. Again differentiating it with respect to x, we have to simplify the tangent equation, okay, equation of the tangent as much as possible. So this is, let me take the first equation, differentiating first with respect to, or differentiating it with respect to, or differentiating it with respect to x, we get, this is d by dx, equal to c into cos hyperbolic x is nothing but sine hyperbolic x upon c. But x upon c is not x. So again, differentiating the x upon c by function of differential method, this is 1 upon c. C cancelled out. This is nothing but sine hyperbolic x upon c. Okay, so d by dx is calculated. Now equation of the tangent. Equation of the tangent will be y minus small y equal to d by dx. X minus x. Okay, substituting value of d by dx is nothing but sine hyperbolic x upon c into x minus small x. This is capital Y minus small y. Okay, so small y. This is the equation, but let me separate them. If I substitute the value of y here after taking that side, you will get the answer finally. So this is y minus sine hyperbolic x upon c into capital X. If I take this as positive or negative, let me take this as positive and y negative. Take y to that side. Okay. It will be equal to x to this side will be x minus y. Okay. So what I've done, I've taken this y capital this side and minus x into, sorry, this is minus x into, this is x into sine hyperbolic x upon c, because sine hyperbolic x upon c is multiplied with small x as well. Okay, this is minus 1. We are taking this negative sine hyperbolic x upon c x to this side, it will be positive, and here minus y is already there. If I substitute minus y, value of minus y, which is x sine hyperbolic x upon c minus c, which is cos hyperbolic x upon c. Okay, so nothing is common. This is x into this. This is the only equation. That means sine hyperbolic xc into capital X minus y capital Y equal to this x into sine hyperbolic xc x upon c minus c into cos hyperbolic x upon c. So it could be only this equation. So this is the answer of this. So further we cannot solve it. X, no, nothing is common, c is not common. Okay. This is the final answer to equation of the tangent. Hence the equation of the tangent is calculated. Now next let me take the next part. So this is the equation of the tangent of this equation, this function. Now let me take key part of this. Now key part of this says that, okay, this is key part. What is the key part here? X square plus y square whole square equal to a. This is a square into x square minus y square. Alright, this is the question number E. E part. Okay, x square plus y square whole square equal to a square into x number. So now differentiating it. Let me take this first equation. Now differentiating first with respect to x, we get, this is, if I differentiate this with respect to x, this is 2 into x square plus y square first. Now differentiating inside, x square is twice x plus y square is twice y first, then dy dx. Okay, close. This is the complete differentiation of this. Now this is equal to a square as it is. In the bracket it will be twice x minus twice y into dy dx. Okay, this is the whole. Now taking dy dx common, or the term of dy dx common or separated, because we have to find out value of dy dx. So what will be the, okay, now 2 is cancelled out, then 1 2 is cancelled out, this 2 is left over. This is twice of this y, so let me take dy dx common. This is twice into y, okay, 2y into this x square plus y square. This is also multiplied. Okay, and from this side we will have minus y into a square. Okay, that means plus a square y will also be there. This is without 2, because here it is 2 multiply, but there only a into a square into y. That's the point. So this is equal to, here it is a square x. Okay, and from this side we will have this x minus sign twice x within bracket, it is x square plus y square. Okay, so this is a square into x. So this is step twice x square plus y square into x will be there. So that will be negative. Okay, now this is therefore d by dx is equal to this upon this a square x minus twice x into x square y square divided by this value twice y into x square plus y square in bracket plus a square into y. Okay, so this is, let me take second equation. Now, therefore, equation of the tangent will be, now equation of the tangent is, we know that this is pi minus small y is equal to dy upon dx into capital X minus small x. Now, substitute the value of dy by dx, which is this one. So it is pi minus small y equal to dy by dx is a square x minus twice x within bracket x square plus y square divided by twice y into x square plus y square plus separately a square y within bracket x minus small x. Okay, now multiplying them and cross multiplying them. Okay, so we get, let me write it here. This is the equation. Let me simplify this further. Further simplification of this will be, here it is twice this whole to be multiplied to this equation twice y within bracket, this is x square plus y square plus a square y this whole bracket into capital Y. No problem. Now into this minus y, this whole term will be minus small y into twice y. That means this is twice y square within bracket x square plus y square. Okay, with minus y into this will be minus a square y square minus a square y square. We are multiplied to this y and small y, okay, with this denominator. Now this is equal to, now the above equation, the numerator into this x minus x, this will be a square x minus twice x within bracket square plus y square this whole into capital X. Now this into a square into minus x, that means minus sign x into this is a square into x square minus minus plus, this is plus sign twice x square in bracket x square plus y square. Okay, this is after multiplication by the numerator, minus x into this minus a square x square, this is plus twice x square into x square plus y square. Okay, now simplifying this further. Now let me simplify this further. Okay, these two steps are, this x, y coefficient, y and coefficient of capital X. These two are similar, so let me take this to this side, x, capital X to this side. So let me take this x, capital X into within bracket. Let me write capital X later. So this will be positive twice x within bracket x square plus y square, and this will be minus a square x. Okay, let me take small bracket into capital X. Capital X. This is positive negative sign. This is negative. This is there into capital X. Okay, into this is already plus twice y within bracket. Okay, this is twice y into x square plus y square in plus a square y into capital Y. Okay, this is equal to, let me solve the right hand side of this. Right hand side of this is x term, this is y term. This y term will be positive, both will be positive to this side. This will be twice y square into x square plus y square plus a square y square. Okay, and this is already minus a square x square, this one, plus twice x square within bracket x square plus y square. Okay, now let me solve this. These two steps are cannot be changed, they will be kept as it is. Okay, as they are. Okay, so now let me multiply them. This is twice y square x square first term plus twice y4 plus a square y square minus a square x square plus twice x4 plus twice x square y square. It can be, if I take two common from these three terms, this is 1, 2 similar terms, okay, and these two. This is twice x4, twice y4, and this and this. So this is 4, and write first twice x4, plus twice y4, plus 4x square y square, and then it plus a square y square minus a square x square. Okay, in fact, a common here will be y square or with negative sign. Let me take twice common from the first three terms. Twice common is nothing but x4 plus y4 plus twice x square y square. If I take minus sign, minus a square common from these two, so x square will be positive, minus y square will be negative. Minus y square, I mean, y square will be negative. So that is this term. Now x a square, x square minus y square, this value, this one. Okay, if I substitute value of this is nothing but twice x square plus y square whole square. This is minus a square into x square minus y square. So the similar value, this one from first, x square plus y square is equal to a square x square minus y square. Can we substitute here twice a square x square minus y square minus a square into x square minus y square? Means one term is left over. This is twice similar value minus a square into x minus y. From first one, this is from first. What we left over? Only one term will be left over. That will be, let me write here. This is equal to this term plus this term equal to the final value a square into x square minus y square from first. This is from first. So this is the final answer. This is the equation of the tangent line, okay, of the given E part. This is this x times this y times equal to a square into x square minus y square. Okay, so this is simplified from first equation. This is the equation of the tangent for E part. Now let me take F part. Okay, so F part says that, okay, this is F part. It says y equal to c cos hyperbolic x upon c. Sorry, this one. Sorry. This is y is equal to f is by a log of e secant x upon a. Okay, this is the f part. Now let me take this as first, differentiating with respect to x. Differentiating first with respect to x. We get, okay, so we get d by dx is equal to, this is a into log of, differentiation of log of, this is 1 upon secant x upon a into differentiation of secant x again, secant x upon a into tan x upon a into x upon a is not x, so we have to differentiate again, it will be 1 upon a. Now a and a cancel out in multiplication. Secant a x upon a, secant x upon a cancel out. Left over is tan x upon a. Okay, this is d by dx. Let me take this as second equation. Therefore, this is value of d by dx. Therefore, equation of the tangent will be or is given by y minus small y is equal to d by dx into capital X minus small x. Substituting value of d by dx, this is nothing but tan x upon a into x minus small x. This is y small y. Okay, so multiplying this, or if I write it as tan x upon a means sin x upon a upon cos x upon a, that can also be written as sin x upon a upon cos x upon a. Now cross multiplying this, so this will be cos x upon a into capital Y minus y in small y into cos of x upon a is equal to sin x upon a into capital X minus x into sin x upon a. Now separating them, it can be written as, let me take sin x upon a into capital X to that to this side. Now take this cos x upon a into y to that side, be negative. This is cos x upon a into y. This is equal to negative, this will be positive. Y is cos x upon a positive minus x, sorry, it will be positive because we are taking sin x upon a positive, so this will be taken to this side. So x sin x will be positive and it will be negative minus y cos a. Okay, so this is the equation of the tangent line. Let me write it simply in simple form. This is nothing but sin x upon a into capital X minus cos x upon a into capital Y is equal to first x sin x upon a, okay, minus y into cos of x upon a. Now after substituting value of this y will not be satisfied. Will not be simplified further. Will not be simplified further. Will not be simplified further. So we have not substitute value of y here. Okay, only this is the simplest form. This is the equation of the tangent for this equation. Now let me take g part of this, g and h finally. So the two leftover equations are g part. G says that e raised power y is equal to sin of x. Okay, let me take this as the first equation. Now differentiating first with respect to x, we get, now this is dy, differentiation of by dy, but y is not x, so differentiating further by function of a function method is equal to cos of x, so dy dx is equal to cos x upon e by is sin x from first, so cos x upon sin x from first. Okay, substituting value of e raised power y as sin x in the denominator, so we get cot of x. So d by dx is cot x. Therefore, equation this is, let me take d by dx as second equation. Therefore, equation of tangent is, let me take, is, okay, y minus small y is equal to d by dx into x minus small x. Okay, the full value of dy dx, which is cot x into x minus small x, y minus small y. If I just simplify this, because e raised power y, if I cos upon sin by cos x upon sin x, if I substitute this as sin x into x minus x, that can also be done. Let me cross multiply. This is sin x into capital Y minus small y into sin x equal to cos x into capital X minus x into cos x. Okay, substituting value of y is cannot be substituted. So only this is the simplest form. Let me take cot x was the simplest form. Only this can be, okay, could be written as cot x into x minus x, because y is cannot be eliminated, or if I take log of all both sides, then y will be there. Log of e raised power y is y, log of sin x, value of y if I substitute this log of y. law of signing, sorry. That is not a simple form. Only this is the right thing. Or it could be written only y minus small y equal to cot of capital X minus x into cot of x. This is the simplest form. Because it is okay. Or could be written like this. Okay, both are same. Either this or this. This is the simplest one. Cot x into x will be cot x. Capital X. Okay, or cot x. If I write cot x into capital X minus y is equal to this, where now I've taken y to the side and this to the side, so this will be x into cot x minus y, small y. Okay, this is also answer. This is the answer. Simplest one. Okay, so now this is G part. Let me take the H part of this question number 5. The H part of question number 5. This is the last one of this part. I mean this question 5. This is 5. So this is H part. H part says this xy equal to k square constant. So nothing but k square. Okay, so differentiating this is first equation. Differentiating it or first with respect to x. B get this is by product rule. Okay, so applying product rule, this is x into d by dx. X as it is, y differentiation is d by dx plus now y as it is, x is 1, y k is 0. Differentiation of k square is 0, k is constant. Therefore d by dx, this implies that d by dx equal to minus y upon x. So let me take second equation. Therefore, equation of tangent is given by minus small y equal to d by dx into capital X minus small x. Substituting value of d by dx, which is minus y upon x, minus small y upon x, capital X minus small x. Okay, so if I take y to the side, it can be written as y upon small y minus 1. Sorry, this is okay, minus y if I take to the side, it will be either plus 1 if I take minus sign and divide this by x, or take minus sign here only, y take to the side, it will be 1 only. Okay, this and x I take this side, minus x, minus 1 upon x. So this is minus capital X upon small x. This is minus 1 plus 1. Okay, so it will be